So welcome everyone. Thank you for attending today the Serverless Days in New York. I'm going to talk about how to scale your serverless teams with the Aws Cdk. I'm actually subbing in for Ben Elby, who's the CTO of Aws, our sister company in London. Ben is unfortunately sick with COVID, so he could not join us today. And credit where credit is due, a lot of this talk is based on his work. Ben manages the serverless information website and blog, where he has a lot of great content about serverless. I encourage you guys to check it out. He's been recognized for his work as an AWS serverless hero. You can find him on Twitter at LBBen. Go check him out. He's got a lot of stuff. For my part, I'm Aws Cdk. I'm the VP of Engineering at Theodo here in New York. We have a booth right there. Come check us out afterwards. You can also find me on Twitter at @aldebout. I'm a lot less active than Ben, so there's one of the Twitters that's better than the other. So why is it hard to scale serverless teams? And this is really what we're going to focus on today. When teams, especially in bigger companies, switch to serverless developer teams, they usually make a lot of promises, right? They're like, okay, we want change, we want to do serverless, so we have to show improvements that come directly from this to be able to justify the organizational and technical and technological change that's required. And so then we make promises about security. We make promises about speed, right? We say, hey, we're going to deliver more features faster. We also promise that we're going to have fewer bugs in production, that our product is going to be more stable. We also promise that we can be more reactive to a changing business environment, and that if we have changes that come from the user side, we'll be able to implement them pretty quickly. We also say, hey, we'll be less reliant on other teams. We'll need less help. We'll be more autonomous. One last thing, because I'm a developer, that I want to add to this list is that as developers, we also want to be happy. We want our whole teams to be happy, and this is something very important to optimize for as well. So the two areas that I want to focus on today when making that transition and trying to scale with serverless developer teams, the first one is our top-down approach to security. That's kind of the classical approach, and so we'll talk about this. The second concept that's very important to me that I want to talk about is the team cognitive load and how we can reduce it. And today we'll talk about a technical approach to it through the CDK, but that's not the only thing, right? This is like a combination of organizational changes and a technical solution to help them. So this is, I think, a very classic way to look at security and infrastructure, especially in bigger corporates. You have a lot of development teams, and they do a lot of good work. And then when they need infrastructure, or when they want to deploy a thing and we want to check that everything is secure, well, there's a big infrastructure and security team, and we ask them, right? So let's say I want to deploy an S3 bucket. I'm a developer. I'm going to ask the team. Maybe I'm going to open a ticket on some kind of tracking system. And then a week later, I'll get something, and then it won't be what I wanted, so I'll go back and forth. And then when I want to push my code to production, someone from the security team will take 2 days to go through it, and then have a lot of comments, because usually I'm a developer. I don't think about security first. It's hard for me to know what to do. And I don't know, I've waited weeks at times in previous jobs for my servers to be deployed or stuff like that. And this is not dumb. There's a reason why it's like that, and that's because before serverless, and especially before the cloud, but even still with the basic cloud, when we've got EC2s and stuff like this, it's hard, right? You need your servers, you need your VPCs, you need load balancers, you need your databases, you need all of this provision, scalable, secure. But once you've got everything, you can pretty much do anything you want, right? You've got a server, you can put whatever you want in it, you can do whatever you want as code. And so having this big top-down approach of okay, request your thing, and then we'll tailor it and take a few weeks to provide it to you, it kind of makes sense. But when we switch to serverless, we have a problem, because now our infrastructure is code, our code is infrastructure. We use a lot of managed services. And so as a developer, anytime I want to write a feature, I'm going to add something to my infrastructure. And this becomes a problem if I need to ask for my infrastructure, if I need to get everything checked every time, because the friction becomes just becomes a huge problem. And so the security and infra team become a bottleneck for my actual output as a development team. And so what I'm going to talk about today is how we can revert this trend to have a bottom-up approach to infrastructure and security, to have actually teams that can enable the development teams in their job and allowing them not to have to pull everything, but to be able to use ready-made blocks, a platform product, to be able to develop and go to production really quickly. The second thing that we're going to talk about is cognitive load on teams. And spoilers, I'll talk about a book later. But let's say you're a development team, you have limited space in your heads. And there's a quote by Dan North that says that we should work on software that fits in your head. Because if it doesn't fit in your head, then you have to context switch all the time, and it becomes really hard to build something that's quality quickly. So here we've got a little developer, and they have limited space in their heads, and there's already some stuff in that head, right? I'm working on the project, I'm thinking about my deployment flow, I'm thinking about the comments that I need to be able to go to prod, I'm thinking about the security standards of my company that I may know approximately well, and that already takes a lot of space. The second thing is that I have a huge ping blob here, and that's all the context, all the business context and product context that I need to be able to develop new features. Let's say I'm in e-commerce, I work for an e-com platform or website. If I have to develop a new feature, I need to know about user flows, I need to know about the UI design of the platform, I need to know about all the different scalability requirements, I need to know about a lot of things. And that's a lot of things, and so it can become too big for my head. It can become too big for to fit in my head. So we're going to try to do two different things. The first thing is that we're going to try to split up this big pink blob of product knowledge and business knowledge into smaller tracks. And this is domain-driven design, and this is a pretty, I think, now standard approach. And so we're going to try and identify in our big business domain, what are the subdomains that we can have individual teams work on. And to do this, we try to split them up, limit the boundaries between them, so that everything works well. The second thing that we're going to do, and this is what we're going to focus on, is that we also want to remove all of that, thinking about my company's security, thinking about how to deploy stuff, thinking about, what day is the right day to ask to go to prod because they have they have less work on their calendar and stuff like this. And so we want to remove this as much as we can to be able to replace it with more valuable knowledge about the product, about what I'm actually trying to build as a developer. So it all starts with a team structure. And Cam, this next slide is for you. There's a famous law called Conway's Law that states that any organization that designs a system will produce a design whose structure is a copy of the organization's communication structure. And I'm sure everyone has experienced this. You're building a product, and then maybe you have 3 teams working on the product, and there's one of them that maybe has a little more trouble communicating with the other ones. And in the product, it really shows, actually. There's one of the elements of the product that does not communicate as well with the other ones, and you end up with bugs. But the cool thing about this law is that if you revert it, and this is a really cool slide, pretty tricky, right? If you revert it, if you think about the way you want your final product to be designed you can also organize your teams in a way that's going to fit this. So by thinking about your organizational structure well in advance of building your product, or at the very beginning, you can actually reduce the impact of your organizational friction by making sure that your teams are well organized to fit what you want to do with your product. And so to help us do this, there's a wonderful book called Team Topologies by Matthew Skelton and Manuel Pais. I think it came out in 2019. It's called Team Topologies. It provides us with a framework to organize our teams, our development teams, for flow and speed. And what they offer, like, it's a really nice book, you should go read it. But in the book, they offer 4 team topologies. And so I'm going to go through them. The first one is the stream-aligned team. So at the top in yellow, so the stream-aligned team is going to work on features, usually user-facing features, and they're going to be assigned to a domain. So we've split our pink blob into smaller pink blobs, and then every stream-aligned team is going to take one of them. They're going to be delivering features. That's kind of what we think usually when we think of a development team. The second type of team is going to be the enabling team. They're usually going to help the stream-aligned teams work on their product by training them, by providing them with more resources during crunch time. They're going to maybe identify missing capabilities in those teams and then act to fill them. And then the third team is the complicated subsystem team. And this is, maybe you've seen stuff like that on your product. You have a product, has a lot of features, but there's 1 or 2 areas that have a lot of technical complexity. And every time you change the team on this, you get set back by 6 months of development. For example, for a client, we had a team that was dedicated to maintaining a 3D on the browser library. It was highly complex, and so we're like, okay, you guys do your thing, and then you make it good, you make it so that it fits everything that we need in terms of performance and features, and then the other teams are going to leverage that for the actual user-facing features. And the last team, and the one that is the most relevant to this talk, is the platform team. And this platform team is a bit different from our classic infra and security team because the platform team wants to enable all of the other teams with a platform as a product. And so they're actually working like a product team. So they're going to go do interviews with the other ones. They're going to gather user requirements. They're going to get feedback, and then they're going to output some platform elements. And we'll see with the CDK what form this can take, so that especially the stream-aligned teams can focus on what matters to them, the features, without being slowed or without having to think about extraneous data. This is an example of what it could look like, the organization. So you've got the platform team outputting their platform as a product. You've got different stream-aligned teams working on your different domains, outputting features. The enabling team would be rotating between them, helping them, making sure that everything is doing all right. And then the complicated subsystem team is kind of on the side, making sure that their complicated subsystem is working well and improving. A side note, to help you separate your domains, Ben LB has a great workshop on to do this, to split your domains, called Event Bridge Storming. It's inspired from event storming, but adapted to the serverless patterns and event-driven design. And if you haven't heard about this yet, I would encourage you to Google it. It's a really interesting talk that he's given multiple times. I'm pretty sure he's got a few blog articles about this. Go check it out. We use it a lot with our clients at the beginning of projects. So now let's get back to focusing on the platform team. How can we enable this team through technology, and how can they then enable the other teams through technology? I'm going to talk about the AWS CDK, which is the one infrastructure as code framework that we haven't talked about yet today, I believe, for AWS. And so the CDK basically brings infrastructure as code in a classic application language format. So you can use a CDK with Node.js, you can use it with Python, with Java, with C#, and a couple of other ones that I'm forgetting. I think Go is in beta. And it's kind of like similar idea to Pulumi for those that have used it. And so because it brings us like those classic languages, it also comes with all the goodies that we've been developing for 40 years plus of software engineering. And so CDK constructs, the basic elements of the language, are classes. So they come with abstraction, they come with encapsulation, they come with composition. And for the platform teams, it allows them to hide complexity, to provide sensible defaults to those different constructs, and to protect dangerous settings from accidental changes. For the streamline teams, it allows them to then leverage those constructs to combine them, to just fill out their use cases. To achieve this, in the base CDK made by AWS, there's already a hierarchy of constructs. So L1 constructs are AWS CloudFormation only constructs, or generated automatically from the CloudFormation spec. So here, for example, we see that we use a CloudFormation bucket construct, and we name it my bucket, and we name it my bucket again. And this is like basically raw CloudFormation. It doesn't change much. You would still have to provide a lot of parameters that are not always very happily named, and to actually have something that works. So this is cool, but this is not that interesting. With L2 constructs or curated constructs, it starts to get a little better. So the L2 constructs encapsulate the L1 constructs, and they provide AWS best practice defaults and policies. So here, for example, we're again creating a bucket, but it's a higher level bucket that's going to have some defaults, and then we can just do version true instead of maybe having to do like a couple of properties to achieve the same result with the L1 construct. And this goes for there are a lot of L2 constructs. L3 constructs are patterns. So instead of being resource-oriented, they are task-oriented. So they often already combine multiple AWS services to achieve those results. And typically, you will have a lot fewer configuration options for them, just enough to make them fit the major use cases. There's a great repo, cdkpatterns.com, that Jerry mentioned. There's also a lot on serverless land. And to give you an example of what this could be, recently I was adding a data ingestion pipeline from logs into NS3 for a project through Kinesis Firehose. It's about 70 to 80 lines of code in CloudFormation. It's 5 to 10 with the CDK, and it looks a little better. So what does this mean for our platform teams? It means that as a company, we can start to bake in our best practices into L2 plus constructs, or whatever we want to call them, so that the company-specific, or even sometimes the project-specific, if they're big projects, configuration settings can be by default in everything that we use. This is especially important from a security standpoint. Let's say that we have a company that has very few reasons to have public buckets, and I think that goes for most companies. We're going to say, hey, instead of using the default bucket, we're going to use the base bucket at the company level, and we're going to bake in the fact that it has a blog public access policy by default. This way, developers cannot have a public access bucket by mistake. Let's say we're a company that uses a specific encryption standard. Maybe we're in a highly regulated industry and we have to conform to SOC 2 certifications and stuff like this. We cannot use the default certification. We have a very strict key policy. We can also bake this in our base bucket. We can also have a standard ACL. Anything is possible. The main gain here is that if I'm in a stream-enabled team, I do not have to think about this. Before that, every time I would get a template, I would copy-paste something from another project. I would be like, oh, wait, has the encryption standard changed since that code was written? Is it up to date? Am I doing well? Well, it's now we don't have to think about it, and I think that's pretty neat. And the really, really cool thing to me is that because what we wrote is code in a classic language, we can also manage our dependencies on this infrastructure as code the same way that we would do with any library. So let's say you wrote a node, you're going to publish an internal NPM package. So the platform team is going to publish an internal NPM package fulfilling that promise of platform as a product that then all the development teams can pull into their projects as classic dependencies. So, that's pretty nice. As a developer, you're just hey, I'm going to npm install my base bucket and then use it anywhere I need it. And maybe I'm going to get higher level constructs. Maybe I'm going to get all of my resources like this because my platform team just provides me with everything I need, and I do not have to think about any kind of security anymore. And for the platform team, that version management is also really important, right? Let's say that the encryption mechanism changes at the company level for whatever reason. Maybe there was a key, we had an issue, some regulatory change. Well, that's easy. You just change your base bucket and you publish a new version of your package. And instead of having to go through all of the source code of all of your repos to check if someone has failed to change like a template somewhere, you can just do audits of dependencies. And that's something that we already do for a lot of reasons. So that's a mechanism that we're used to. And I think that's pretty cool. And so finally, we are getting to this model where the platform team provides the development teams with everything that they need that already has baked in security and baked in best practices from the company level or from any level. Let's keep in mind that this is not a fix-all, it's not a cure-all. This is going to help us, and especially help us reduce the cognitive load on developers. It's going to help us with security reviews. But let's keep some kind of top-down, especially in terms of service control policies. We do not want rogue accounts or policies going around with max permissions. We need to keep permission boundaries. We need to keep using good tools like the control tower. But using both in conjunction really, really helps us achieve our goal of developing faster and having less friction between the different teams, and in the end, having happy developers. The CDK then enabled us also to abstract the complexity that developers previously had to think about in the stream-aligned teams, and now put it entirely in the realm of the platform team. So we're finally turn that little purple blob to a pink blob. That's wonderful. In conclusion, because the CDK brings abstraction, encapsulation, and composition, we can enable a bottom-up approach to security and compliance. And I think that's the main point here. We can structure our teams to reduce cognitive load using team topologies, and go read the book, please. And CDK constructs or similar mechanisms that are based on classic application languages are a natural fit for platform teams to build a platform as a product. And let's not forget that to combine this with a top-down approach with some guardrails still, because you don't want to be that guy. So yeah, thank you very much for listening. Again, go check Ben Elby's blog. It's great. I'm Alex DB, the VP of Engineering at Theodore. We have a booth right there. Come talk to us and ask questions.